My name is Safir, and I would like to welcome you to Safir Academy. Here at the Academy, we teach
chemistry, economics, and of course, Algebra 2 trigonometry.
No, Shineman.
Now that's better.
The first lesson for today is fractional exponents.
What are fractional exponents?
Fractional exponents are an alternative way of expressing roots.
For example, Dan, 4 to the 1/2 is simply radical 4 or just 2.
Interesting. So you're telling me that 27 to the 1/3 power is 3?
Exactly, because when you did 4 to the half power, the 1 was the power and the 2 was the root of the radical.
So, for example, a to the 3/2 power would give you the square root of a to the 3rd.
So what would be 2 to the x over 5 expressed as a radical?
So first you would have to put 2 under the 5th root.
Then you would have to raise 2 to x. The answer would be the 5th root of 2 to the x.
So let's talk about the cubed root of a to the 5th.
Since 3 is a root and 5 is the power, and fractional exponents are expressed as power over root, it would be expressed as a to the 5th over 3.
Let's do a more complicated example.
So what's the cubed root of parentheses 9p squared?
Since we are finding the cubed root of 9p squared, we would put the 2 as the numerator and 3 as the denominator in the fractional exponent of 9p.
I understand. Fractional exponents are another way of expressing roots, so that later on in the lesson, we can use them to solve complex fractions.
Precisely.
So now let's move on to multiplying and dividing fractions.
What are the steps of simplifying these types of expressions?
Think about middle school, Dan. First, you multiply the numerator.
Then multiply the denominators and simplify where necessary.
So how would you do 2 over 3 times 2 over 5?
First, I would multiply the numerators, so 2 by 2 and I get 4.
Then you multiply the denominators 3 and 5, which will give you 15. So your answer is 4 over 15 because you can no longer simplify it.
So a more complex example would be 1/2 times 2/5.
Let me try this one. So I multiply the numerators, which are 1 and 2. And then I multiply the denominators, which are 2 and 5. So the answer is 2/10. So I'm ready for the midterm, right?
Not quite, Dan. You then have to reduce to 1/5.
It's okay, Dan. I have another problem for you. 2 over 3 times 5.
Wait, hold on. 5 is not a fraction.
See, Dan, all whole numbers can be written as that number over 1. See, when you multiply the numerators, you get 10, and when you multiply the denominators, you get 3.
So the answer is 10 over 3, which can't be simplified. Now let's add variables.
So when you add variables, you have to factor numerators and denominators before you multiply.
Then you have to eliminate common factors, then simplify.
So 3c over 3d times 3cd squared over 4a.
First, you have to factor the numerators and the denominators. You factor out 3 from 3c over 3d to get c over d.
At this point, you multiply through, so you get 3c squared d squared over 4ad.
Now recall from before, we have to simplify. There is d squared in the numerator and a d in the denominator, so you can take out a d from the numerator and eliminate the d from the denominator.
So the answer is 3c squared d over 4a.
Let's try this expression. 18xy cubed over 7a squared b squared times 35a squared b over 12x squared y.
So let me apply these steps for the problem. So the 35 in the numerator can be cancelled out with the 7 in the denominator. The 18 in the numerator and the 12 in the denominator can be simplified to 3 in the numerator and 2 in the denominator after being divided by 6.
So a squared cancels out with a squared, and the b cancels out with b squared, leaving a b in the denominator.
The x cancels with x squared, leaving an x in the denominator. The y squared in the numerator and the y in the denominator can be divided by y, leaving y in the numerator.
This leaves you with 3y squared over b times 5 over 2x. When you multiply across, you get 15y squared over 2xb.